So now let's do an example. In the following situations, if f equals 12 centimeters and O equals 36 centimeters, find the image and the lateral magnification by using a ray diagram and a mirror equation. And f equals minus 12 centimeters and O equals 36 centimeters. So we're going to do a plus and a minus, and I'm going to show you how to do this. Okay, here's my hint for you. This thing that I wrote here, write it on that piece of paper that you're going to be working on every single time until you get familiar with this. So first of all, I'm going to write parallel here, and then I'm going to write, for my own self, I'm going to write chief, and then I'm going to write focal. Right, just so that I know what colors I used for what rays. Now let's do the problem. And the reason why I messed up on this is because I was not drawing it to scale. Now let's actually draw it to scale. So remember this slide the way it is. So I'm going to do, first of all, the positive axis, but it actually gives us some numbers. It says put your focal point for your positive lens. I'm going to erase one of these, and I'm going to do it one by one. So it says that my positive focal length is 12 centimeters, and my object is at 36 centimeters. So if I was to do this properly, I'm going to need a ruler. So first thing I need to do is I'm going to draw a straight line across with my ruler. That straight parallel line, hopefully this is going to be a straight parallel line, is going to be my optical axis. On this, I'm going to draw a line here that is going to represent my mirror. This is a positive mirror. See, this is going to tell me that this is a positive mirror. Why is this important? You'll figure out in a second when we do lenses. So then I'm going to draw my object. First of all, it says my focal length is 12 centimeters. So if I'm drawing everything to scale, you have a smaller ruler, I have a larger ruler. I'm just going to call 1 centimeter for me to be equals to, if I'm going to draw 12 centimeters here, I'm just going to use 10 and 12 from here. So for me, if I start doing it at 60, it's going to be 10, 11, 12. This is where my focal point is going to be. And I want you to draw 10, 11, 12. Your second focal length will be behind the mirror. So this is going to be my focal and my focal at the back. Okay, so it says my focal length is at 12 centimeters. So for me, this is 12 centimeters, and this is also 12 centimeters. Oh, I just erased it. Then it says that I have to place my object at 36 centimeters. So I'm going to start here in the middle. So I'm going to go 10, 20, 30, 4, 5, 6. So that's where my 36 is. So my object is 36. The other thing I would highly recommend is that you always keep your object the same height. So for me, it's going to be 10 centimeters because I'm drawing them to scale. But that's going to be my height of the object. So this distance is 36 centimeters. This distance is 12 centimeters. Yes, of course, scaled up, right? Okay, now comes the interesting part. How do I do rays? So I'm going to start over here. My positive ray, which is my parallel ray, is going to be parallel to the optical axis. Oh, my ruler keeps moving, sorry. And then it's going to go through, because this is a positive lens, it's going to go through this focal point. Goes through this focal point. So that gives me my first ray. Okay? My second ray is going to be my chief ray. And my chief ray goes from the top to the bottom here. This is my real ray, goes here. Now, how do I make sure that my angle is absolutely correct? That's why I said make sure that the height is the same. So if you were to take this height, that's 10 centimeters, and this height here, it guarantees that these two angles are going to be exactly the same. Well, as much as I can guarantee, right? So this is going to be going that way. So this is going to be my chief ray, and this is going to be my chief ray. So that's my chief ray. The last ray is going to be my focal ray. What does a focal ray do? The focal ray goes through the focal point. This is a mirror, so it will use the same focal point for all of them. So this goes through the focal until it hits it. It's going to go from here through the focal, hits the wall, and then it's reflected back. And if I've done this all correctly, they should all match up. Right here. This is the spot where they all match up. And that is the spot where I'm going to get my image. So this is my object, this is my image. Now what is my image distance? It says find the position of the image. So how do I find the position of the image? I literally just measure. Again, remember, everything is measured from the lens or the mirror. So I'm just going to measure this. This is going to be, if I put this at 90, 10, 11, 12, 13, 14, 15, 16, 17, about 17.5. So my image is at 17.5 centimeters, and my object was at 36 centimeters. Now how do I find magnification? Magnification was equals to I over O, which is 17.5 divided by 36. And obviously I can see that it's smaller than this one, right? Now, the other thing that the questions asked us to do was to find it by using the mirror equation. So the mirror equation was 1 over F equals 1 over O plus 1 over I. So my focal length was 1 over 12. My object was at 36 plus 1 over I. So I can do 1 over 12 minus 1 over 36 equals 1 over I. I will let you guys calculate that on your own. Just figure out whether this I matches up with this I that I measured. Next scenario is exactly the same equations, exactly the same problem, except now instead of having a positive focal length, I have a negative focal length. How does that situation change? Well, that situation is very different. So your mirror now, instead of being a concave, will now be a convex mirror. So the way you draw a convex mirror is this one. That will help you figure out that this is a convex mirror, so it kind of goes like this, just so you know. Okay. Rays will remain the same, however, because this is a convex mirror, it will not have converging rays, right? So things will change. So I'm going to leave the rays as they are for the ones that are not going to change, but there are rays that are going to change, and I'm going to change them. Okay, so first off, parallel will go parallel, so that's good, except now it is not going to converge in. What is it going to do? It is actually going to diverge. But by how much? Well, it's going to diverge by the amount that it goes through here. Like that. Do you see how I draw these rays? Because these are not really there, they're just virtual, but parallel in this case will go like that. So this is for a negative sign. So this is a comparison for the positive, but this is for the negative now, right? So this is not going to hold true. Okay, now what about the next one? What does a chief ray do? Well, chief ray stays exactly the same. It doesn't matter which one I'm going to look at it from. So the chief rays goes in here, and the chief ray gets reflected back the same amount. sort of, right? Because this was about 10 centimeters, so this should be about 10 centimeters. Yep, and I'm off. Okay, here's the thing. The more careful you are at drawing this, the better your results are going to be. Right? Do you see how I put a dot here? That's 10 centimeters and that's 10 centimeters. On your paper, I would suggest that every single one of these 10 centimeter lines, so if it says 12 centimeters, I can put 12 centimeters. But on your paper, I would recommend that you convert it to a unit that's normal. Like for example, I usually convert 10 centimeters to be equal to 1 centimeter, so it kind of fits nicely onto my page. So remember, 10 centimeters, 1 centimeters on your ruler, right? Okay, so my chief ray does exactly the same thing. It's not going to change much, so that's what it looks like. Now, what about my focal? This is a mirror situation, right? So we can only use one focal point. So in this case, your focal is going to go here. I hope I can draw this properly to show you, but this is where it's going to be. It's going to start here, hit here, go through the focal, and then it's going to be reflected back parallel. So my focal is going to go here and here. Do you see these dotted lines? The reason why these are dotted lines is because these are virtual. These rays don't actually exist, but they help us. Now again, same problem. I don't have anywhere where they're all converging. So how do I solve that problem? I'm going to redraw this extending forward, right? Extending forward. Two rays meet up. Question, will the chief ray also meet up? And the answer is hopefully, hopefully, hopefully. Yes, it will. Okay, here we go. Here we go. There you go. Right here. That's where all of the rays meet up. And this is where the image is going to be formed. It is upright. It is virtual. It's behind the mirror as we expect it to be. Okay, now let's figure out what the image distance is going to be. Okay, so my image distance is about 10. So my object distance for this one was 36 centimeters, and my image distance is 10 centimeters. Again, to confirm whether your image was correct or not, you are going to use the mirror equation. In this case, your focal length was -12. Your image is I, because that's what you're looking for, and your object is at 36. So this is going to be -12 minus 1 over 36 equals 1 over I, and I think it will come out to be about 10 centimeters, give or take a few. Okay? Again, remember, I'm doing this on the board, so I can't be that precise. You, on the other hand, have to do it on a piece of paper, so you have to be really, really precise. But this gives you a sort of idea of how the different rays behave in different scenarios. You just have to remember parallel, chief, and focal.